Select the correct mechanism for the following reaction. So in looking at this problem, we need to look at our starting material and our products and analyze what has changed. So we should hopefully see right away that we started off with a alkyl halide. So we had a bromine, and that bromine has been displaced and it has been replaced by this cyano group. And so we have substituted the bromine for that cyano group. That means that this is a substitution reaction. And so we have two different substitution mechanisms that we need to consider. So we have the SN1 reaction and the SN2 reaction. And so the SN1 reaction is our stepwise substitution. The SN2 reaction is the concerted substitution mechanism. The biggest thing that distinguishes whether or not a substitution reaction is SN1 or SN2 is the structure of the substrate. So for SN1 reactions, the substrate will be a tertiary alkyl halide. And your SN2 reactions will occur with methyl, primary, or secondary alkyl halides. And so looking at our starting material, this is a secondary alkyl halide. So that means that this is an SN2 reaction. So in an SN2 reaction, it's concerted. That means the nucleophile is going to attack the electrophilic carbon, and at the same time that is going to push off the leaving group, which in this case is the bromine. And so that is option C. Now, a few other things that we should notice about this. We should notice that the stereochemistry has been inverted in this reaction. And this is very typical of SN2 reactions, and it's because your nucleophile has to approach from 180 degrees away from where that leaving group is. And so typically your nucleophile and your leaving group would be the highest priority group. And so since this is approaching from the opposite side, it ends up attached to the opposite side, which inverts the stereochemistry. For extra practice to make sure the stereochemistry has been inverted, I recommend that you assign the R and the S to the starting material and to the product.